Hi, my name is Thomas Kim. In this session of video, we are going to learn some basic constructs of C++ language. And if you haven't watched my video, please watch my previous video because this video continues from my previous video. So we will learn G++ defines one macro, one predefined preprocessor macro called preT function, and MSVC, Microsoft Visual C++ defines funcSig macro, predefined macro. These two macros are very handy when you program C++ metaprogramming or template programming. These two macros are very useful. And also type ID expression. This is very good. Type ID is the keyword, C++ keyword. And this keyword is sometimes also very useful. And we will learn auto ampersand. It is a reference called L value reference. L value reference. And this is constant auto reference, L value reference. This is auto ampersand ampersand. This is called R value reference, R value reference. About L value and R value, I will detail in next video, not in this video. In this video, I will talk briefly about L value and R value. And also we will learn decl type, more about decl type, this keyword, and we have to learn declared type and expression type. Also, we will learn decl type auto. When to use the auto and when to use decl type auto. This is newly introduced in C++ 14. Introduced this decl type auto new keyword. So in this video, we will learn this. Say in GNU-G++ defines one macro that is called underscore pretty, pretty, pretty underscore function, function, function underscore. This macro gives us function signature. And in Microsoft Visual Studio C++, Microsoft MS Visual C++ defines underscore func sig underscore. This macro and this macro actually plays the same role. Both two macros shows us function signature. So I will show you in a minute later how to use these macros. Also we will use type ID. This is just a keyword, type ID and expression. And if we put dot here, then name, it gives us expressions, the type name. For example, if we define A, for example, like this, if we define like this, then type ID, A is the expression, dot name. This gives us type name, for example. This will give us char, I say constant, char name. Then name's contents will be, name will be int. So using this expression, we can note the type of name, the expressions type as a character string we can get. This can be very handy when you program meta programming, C++ meta programming. This feature can be very useful when you're debugging. Now we talk about auto reference, constant auto reference, then auto reference. If we define like this, and I will define one other one. Constant int, and I will define a reference. This is reference, L value reference. I would say R, and reference should be initialized reference variable reference R is initialized with I, and I will say constant int reference. I would say RC. I will initialize with this one, C. Now I will talk about this one first. Now if we define auto, I would say A. If you declare variable with auto, you have always initialized it. For example, I initialize with I. Then what will be A's type? What will be A's type? A's type will be, of course, int. A's type will be int. Now I will declare another one, auto. I would say AC. Then we initialize with C. What will be AC's type? Constant int. Const int. Do you think so? Because C's type is constant int, C's type should be constant int. I will talk about this. And in this case, R's type, what will be R's type? I will say R's type is reference. I will say add auto again. Now we have declared reference. No, just say auto. I say AR. We will initialize with R. So R is reference. So what will be AR's reference? AR's type will be int reference. Do you think so? I will talk about this. What about this? Once again, auto. I would say RC references. Oh, we already used. I would say I would say RR, CRR, okay, CRR. We will initialize with RC. Then what will be CRR's data type? Will be constant int reference type. First, let's go back again. Here, I is declared with int. auto A is initialized with int variable. In this case, A's type will be int. In the second case, AC is initialized with constant int. But if you try this constant goes away, just int. AC's type will be int. Now here, at this point, R is reference, integer reference, or AR is initialized with R, reference type. What will be AR's type? AR's type. Integer reference? No, reference goes away. AR's type is integer. Now here, constant int reference RC, and RC here auto CRR. We initialize CRR with RC. Then CRR's type should be constant int reference. When reference goes away, constant goes away. A's type will be int, AC's type will be int, AR's type will be int, CRR's type will be int. So auto means if we declare a variable like this, if we declare a variable using auto keyword, constantness disappears, removes, and R's reference removes. Also constant reference removes, only leaves int. You have to remember this rule. This rule is very important. Now, let's try this. What will be, yes. Now, I hope you remember this. Let's modify it like this. Reference. Now, what will be A's type? Say, A, it is declared like this, auto, reference, A, I, like this. What will be A's type? A's type will be reference. So A's type will be int, reference. Now here, let's see. C is constant int, and AC is declared auto reference. What will be AC's type? AC's type will be constant reference, int, reference. It will be like this. And here, now see, R is reference, AR, reference. We applied reference. What will be AR's reference? AR's type will be int, reference. Now, what will be, in this case, what will be CRR's type? Again, it is declared constant int reference, so it will be constant int reference. Now, if you apply reference here, original data structure. No, original data type. A's type, I's type, reference preserved. Its int constant reference is preserved, and its reference is integer reference is preserved, and the constant int reference is preserved. So when you declare with reference like this, its reference is preserved like this, and also constant is preserved. You have to understand this. So we explained this. Now let's try constant. Now let's see what will be A's type. A is like this. A is reference to constant. So A's type will be constant int reference, because it is reference and constant. So constant integer reference to I. Okay. What about this? This is the same. It will be constant int reference. What about this? This will be constant int reference. Constant int reference. This, of course, will be constant int reference. Okay. You also have to remember this, and I explained this. Now this one. So before we explain, we will compare these two. To understand these two concepts, we actually need to. This is called L value reference, and this is called R value reference. R value reference. Here, L value actually means left value. R value means right value. What is L value? What is left value? What is R value? In old days, in traditional C language, left value means A, like 2, like this. This is with respect to assignment. This is assignment. With respect to reference assignment, A is on the left hand side of assignment, so it is called L value. Okay, and 2 is on the right hand side with respect to assignment operator. This is assignment operator. So this value is called R value. This value is called left value. Left value or L value. This is called right value or R value. But this is not correct. This is intuitive but not correct. And the concept of L value and R value become much more complex in modern C++ language. I will detail about this L value and R value in my next video, but in this video I will just explain L value, R value at this level. Okay? And one more instance about R value. If a function, for example, int return value sum, and this function returns some value, return, for example, pi. This function's return value is of type int. This is actually called R value. return value from function is most of the time R value. About this, I will explain in my next video. So this is L value reference, this is R value reference. For example, this is not possible, auto. This is L value reference. Then I would say L 5. This does not work. Because this is L value reference. L value reference means it has some memory. It should have some memory. For example, this is possible. int a, for example, 5. This is variable with memory. Then we can say auto R A. This works because we can take memory address. Reference means reference, L value reference, R value reference. Reference means memory address. Memory address. Reference means actually memory address. Here, L value reference means memory address. Memory address. More specifically, this memory address reference means memory address is literal address. Literal address. This is also literal address. Reference means, I will talk more about this in later videos. For example, in this case, this is L value. L value reference means it should have some memory location. A's memory location address is assigned to here. Actually, not assigned. It refers this variable's memory location. Now let's see why this doesn't work. Why this doesn't work? In this case, it actually has memory locations. Number 5, this is called literal. It actually has memory locations, but that memory locations expires soon. Okay, so in this case, we cannot actually take permanent memory address. L value reference means permanent. L value reference means memory address, but this address should last. This address, memory address, should last sufficiently long. It still has memory address, but it expires soon. Expires very soon. I will talk more about this. So for the time being, just remember this literals address we cannot take to L value. Okay, but if we want to take this doesn't work. I said if we want to take literals value, this is R value, as I explained previously. R value, this is R value. We need to use R value reference. This is R value reference, okay? R5. Now it works. This is called R value reference. R value reference. So this expression works. Basically, if you want to take the address of variable or object, you use reference. If this variable is L value, we can take using L value reference. If this objects, entities is literal or R value, then we have to use R value reference. Just remember this way. We will show the C++ code in a few minutes later. Then I will explain it more. So how do we find out data type of a variable or an object in C++? For example, if we declare int a like this and auto b like a, if we define b like this, we first declare int a and then we declare b using initializing with a. How do we find out that types of b? There can be various ways, but there is in C++ 11 there is a header file called type trace. In this header file has some type trace functions. Type functions, like for example, is constant. This is a template function. For example, if we provide const int, then it will return value this value will be true. Okay, this is constant is type. This kind of function is called a type function. I say type function. Type function gets argument. This is template argument. Template argument as type and returns value like this as member, static member like this. And there are some other there are a number of type functions. For example, is reference, int, value. Since this is integer reference, is reference will give true like this. And there are some other type trace like is pointer, like this. If int, since this is not pointer, this would be the result would be false. However, if we make it like this star integer pointer, then it will be true. Okay, so if there are a number of type functions, then if we provide type here, this is type, if we provide type here, we can get informations about the type. And another feature I would say, in this case, we can also use DECL type. DECL type A, this is expression, then it will return type. In this case, it will be type, int, for example. Now, if we declare another variable here, int, int, reference, we initialize with a. If we try DECL type this will be type of int reference, like this. For example, but if this is type, say if we put this expression to here, then it will be like this: is reference, because we have to put type here, we can put type here like this. RA. Then, since RA, this will be reference, it will be true. So if we have a variable like this, want to convert it to type, we use DECL type like this. If we put this to this type function, like as an argument, then we can find out whether this variable is reference or not. So please remember this mechanism, DECL type. Now I move to my desktop and I will show you this mechanism. Now we start Visual Studio Code editor. If your sidebar is not open, you can press Ctrl B to open it like this, or you can go View and toggle sidebar. Toggle sidebar like this. Ctrl B. Here we will create a folder like this. O2. I would say deduction. Type deduction. Here I will click plus and I will say deduction. CPP. Here include IO stream. We will include type trace. Include type trace. Type trace include type functions. Type functions are included in type trace, so we need it. And I will define some macro. If defined, if def func 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 it means func if func is defined print sig std cout func std and else if define print sig std cout pretty function to underscore std and there now end if like this. Func is defined in Visual Studio. So if func is defined, it means it is using Microsoft Visual Studio Visual C++ compiler. Otherwise, we are using GNU compiler. I will show you how to use these two macros. I defined print sig macro like this. I will remove it. Save it. Now I am creating a function called template. I will template type name. I will create one function first. The void print int a. We defined one function. We will convert it and we define it print sig. We defined print sig here. This is macro. Okay, we defined and we are using it. Here we can say like this. We can change from this function to like this. Okay, we will use auto first. Void print. We will use like auto a like this. Then print sig. This auto for parameter for function parameter declaration is not yet supported in Microsoft Visual C++ 2017. Okay, it is supported on GNU, GCC. Okay, so I will remove it and I will check it how we use it. Okay, so int mean. So I'm creating. Okay, I'm sending one is integer print 3. This is double, so I save it. So we are calling this function. I am trying to explain how to use this function macro like this. dir cd o2 type deduction g++ SED C++17 or I will say D exe D deduction cpp. Okay, D. Now compare it. 1. This number 1 is passed to this function auto A, and it displays this function. So auto 1 means this is auto 1 first, is type int. So this is type int. Okay, and this print second void print auto, we are passing 1.3 as argument, then this is the auto 1 say double. Okay, this function, this statement shows us how auto variable auto is resolved, deducted. Okay, so we will add one more here, auto b, like this. Now we are passing, this will be character, and say this is unsigned. Now we are passing like this, compile b. Now it says 1, or this 1 maps to auto A, C maps to auto B. So the first one becomes A, the type of A becomes integer int, and the second one auto B, type of B becomes character, like this. And in here, in the second line here, the first becomes double, A becomes double, and B, the type of B becomes unsigned int, integer. So using these macros, we can understand how variables, parameters, function parameters can be resolved, how deducted. We can test like this. And this technique can also use for template class. I will create another one. Now create template, type name T1, I would say type name T2. This is called template clause. I would say here template clause, or parameter clause. Okay, then we will not return anything. Print types. I will say print types like this: T1 A, T2 B, like this. And I will say print C. I made like this. Now we are calling print types, this function. I will copy the same, and then say print types. Like this. Save it. Now build again. D. Now compare this result. They are actually the same. 1 integer, character. We compare these two one. Now double unsigned int. Can you map that these two functions, auto A, auto B, T1A, T2A, T2A, actually deduced? The types of these A and B are actually deduced in the same manner. Okay, but this is not available for Visual C++. So I will disable it to test for Visual C++, MS C++, like this, and I will disable them. Now we will try using Microsoft compiler. cl std C++17. No, I need cl std C++17. fe means output. I would say dexe. Then deduction cpp. Okay, D. Now this is the Visual C++ way. Explain int, character, double, unsigned int. So these are resolved this way. So using these two macros, we can understand how template parameter types are deduced at runtime. We can double check like this way. I will create simple function like this, template tm plat type name t void print type tag. I would say like this, and I will copy it once again here. int a I declared like this. int I will say constant int c I have to initialize. int reference r I would say a int constant int reference rc and c. So we declared variables a, c, r, rc. Now we are using auto, keyword auto here. Auto, I would change it to I like this. Then it should be I. Okay. Now I will change it auto a. So if you declare variables using auto, then you have to initialize. I will specify I, initialize like this. Okay. Here again, auto C. No, I will say AC. Here, C. Auto RC. No. A R R R A R auto ARC RCA then RC. So using auto we initialize with int. Initialize with constant int. Here, initialize with int reference. Initialize with constant int reference type. Now we want to examine type of A. Okay, so How do we get the type of variable A? We can do like this. decl type A. This is A's type. Or if I say like this is I, it returns I's variable I's type int. So I say K. What will be case type? Like this. What will be case type? Case type will be variable I's type int. Then it becomes actually int. It is actually equivalent to int k. It is equivalent like this. Okay. If we say decl type c ck, for example, like this, it is equivalent like this. Constant int ck 10. So decl returns declared. This is declared variables, declared type. So that's why we say decl declared type. Okay, so it returns declared type. You understand this, right? Here I made a mistake. It should be 5. Okay, let's see how we can use this construct. How can we use this equation? See, decl type in parentheses, we have to put a variable or expression, not type. Variable or expression we have to put here. Then this gives type. So if we want to test some variables reference needs, we can say std is reference b, or we can say like this, int value. If this int is this type, this is type. Okay, this is type. So this is type function. This is type. So this is type function. If this type is reference, the value will be true. If reference. So I will say true. Like this. If it is true, then we will print std cout reference. Else std cout not reference. Now we will test this code. Save it. G++ std C++17 O dexe deduction cpp. Okay, not reference. So this is not reference. If we put reference, save it, Then if we compile again, now reference. So if we want to put variable here, we want to put variable here. How do we change variable? So this is variable. For example, R is variable, but we have to convert it to type. We have to get type of this variable. How do we do that? We can say decl type. So we are using this construct, declare the type of R. It means now if we try it, D reference. Now it works. Now let's try with this one, RC. This is also reference, RC. Okay, save it, D reference. Now we want to test constantness. Okay, if we want to test constantness, here, now we have const. We can use this const. Here, not const. Now I'll see. We will try first with this C. I saved it. See, reference. This reference comes from here, and constant comes from here. So C is constant. So the result is constant. Now we try with RC. RC. Not constant. See, RC is constant, but it reports not constant. What's the problem? So this works properly, but this doesn't work properly because this is reference. We have to remove reference here. So we have to do this. std remove reference t, this one. Sorry. Remove reference. Then this we have to put t underscore t like this. We have to do this. We first remove reference here. We first remove reference. Then we apply constantness. Now let's try it. I made a mistake. Remove reference T is not a member of std. Remove reference. Runs. Okay, it works. So if we want to test the constantness, we cannot just is constant. We have to say remove reference first, then we do constant. We will make this a function like this, copy it here. I will make it a template. Type name T. Here using is constant. I haven't explained it yet. Here I will say t, and I can actually remove it. Then here I can put t. Okay, then save it. Then we can do like this. Like this, and this is not necessary. It becomes clean like this. When we test the constantness, we have to use this one. It first removes reference, then apply constant. I will talk more about this in next video. Okay. Okay. I will test it. Why it gives error message? I'll try again. STD is const t std remove reference t okay. I think it's not working. We have to do like that. Use const type. Sorry. We have to do this. Okay. Okay, it works. So RC is determined as constant. So we will put more here to compare DECL type auto DA equals I will declare more. Then here it will be DAC, DRA, DRCA, here C, R, RC, save it. Okay, so we are comparing these two types, RA's type, DAC's type, like this. We will compare with this one. Let's see. We actually can reduce like this, B. Then we don't need this. So here R, C, RC. Here I will say RC is reference, RC is not reference. I will say like this. Saved. Now I will copy it once again. Sorry, this is not RCA. RCA, 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 RCA. Okay. Now here, this is DRCA. DRCA, like this. DRCA, and it will be DRCA, DRCA. Okay, save them. Now we put it once again, save it. We put in wrong place. We don't need it. And we don't need it. Okay, save it. See, we compare. RCA is not reference, not constant. This is not reference, not constant. This is just int in case of auto RCA. DRCA, DCL auto DRCA. In this case, it is reference constant. This is reference constant. This is not reference, not constant. So this way we can compare the difference between auto and DCL type auto. We have to understand the difference. So please try more about the type of deduced type deduction, more about type deduction. Please try it by yourself, and also I will explain more in next video. Thank you for watching.